Two words. First word is representative of what component of the organism? What part of it? You're good. Just a little review. Genus and species. Beautiful. All right. What else is lost? Good. So genus and species, two words. Now when we're writing it, right? Binomial just simply needs two names. That's all it needs. Two words. Genus and species. Oh, you just read the screen. That's right. That's called being smart. Okay? So the genus name always capitalized. The second name, the species name, is not capitalized. So when you're typing it, so if you're typing it up for lab, if you happen to be typing it up for a quiz, it's italicized. So when you're using a word processor, or if you were typing it, it would be italicized. All right? If you are handwriting it, you underline it. So if you're writing it by hand, you underline it. Okay? Simple. Now, after you've talked about this organism once, you can then simply abbreviate the genus E. coli. So we've all heard of E. coli, right? Okay, because we've all heard that, then you can abbreviate the genus, and then you write out the species. Simple. What if I'm talking about all of the species within the genus Escherichia? If I'm referring to more than one species within a genus, you use the word species. So I'm talking about the whole species here. Now, what do we notice that's different about the word species compared to Escherichia? It's not italicized. Why is that, do you think? Yeah?
It's not specific.
It's not specific. Awesome. Yes. And here's another little, if it doesn't sound Latin, you don't italicize it. Okay? So, species, you don't italicize the word species. So you would you're talking about the whole species. Escherichia species. Species is not italicized. If I were writing this by hand, species. I underline Escherichia, I do not underline species. And then, if I'm going to abbreviate it, notice how if I'm going to refer to the Escherichia species the second time, I don't shorten the genus, but I shorten the word species. Okay? So just know how to refer to organisms by their proper scientific name. It's important. Right? We're going to see a lot of that here in this class. And my screen froze. Lovely. Okay. All right. Finally. Now we're going to talk about matter. Finally, we're going to start talking about diving into how these atoms start congregating, start forming communities that make life possible. That's what it is. Communities make life possible. Interaction makes life possible. Life does not happen without interaction. Okay. At least life on the planet Earth. So we start the most basic. All right, we start with the most basic. And we talk about an atom. It's just an element. For the most part, atoms all have how many? They have three components. I say elements. They have three components. What are the three components? Christina. Protons, neutrons, and electrons, right? And protons, they have a what kind of charge? Positive. Neutrons are neutral. Oh, and the electrons are negatively charged. Okay. So typically, an atom will have all three of these. Hydrogen atom does not. It only has a proton and an electron. We all know that the center of these atoms is the nucleus, right? That's typically where we have the protons and the neutrons. And then the electrons are just like moving around. Energy. Electrons give the atoms the energy. Crazy. You know, you and I, we are just very highly organized examples of energy. That's it. Really. When we talk about the material world. You think that most of what we see is 99.9 something percent empty air, empty space. Anybody ever see The Matrix? Okay. I'm like culturally and I'm locked into my little world, which is what The Matrix is all about. So I'm going to make lots of really bad cultural references that are from 1983 to 1990. So if you don't understand any of them, that's okay. I just won't like any of you. No. So The Matrix, there's a scene in The Matrix where the little girl says, "There is no spoon." Oh, there is no spoon. He's bending the spoon. Because the spoon is mostly empty air, empty space. But yet, these communities make life happen because of their interaction, the way they interact. So, it's all about the interactions. Oh, there we go. Okay. What are the four elements? Let's see if you've done those who've done some reading. What are the four elements, this is a table of elements, that are most prominent in life forms here on the planet Earth? You ready to put your hand up, John? Carbon, hydrogen, oxygen, and nitrogen. These are the big four. Right? Carbon, hydrogen, oxygen, and nitrogen. Easy. How do you remember those? This is your biology professor. Father Chon, right? Yes, that's how you remember that. Okay. So carbon, hydrogen, oxygen, and nitrogen. Carbon, hydrogen, oxygen, and nitrogen. Now, this elemental table, this table of the elements, what's the importance about these numbers? What are these numbers telling me? They all have assigned a number. Like carbon says is elemental number 6. What does that mean? What information is that telling me? Anna. Okay, so carbon has 6 protons in the nucleus. So carbon is, right, it's number 6. So that means it has 6 protons. What else? What else can I say about this? Number 6. Yes? Number of, did you say valence? I can figure out the number of valence electrons. Okay, so in addition to telling me how many protons it has, it also tells me how many electrons it has, right? Absolutely. Or as Rocky Balboa said, absolutely, absolutely, absolutely. Yo, Adrian. All right, good. So let's talk about carbon. This is probably the hub, right? We are carbon-based organisms, most of us on planet Earth. There are some that are a little different, but elemental carbon has 6 electrons. Now, is it Aiden? So Aiden says, there's a way around that. Aiden says that this can help us determine the number of electrons. There we go. The number of electrons. Oh, lost my dry erase marker. It's on the side. That's the chalk eraser. That doesn't work. Well, you know what? So, you need to see it. Don't tell me how. So, monk's got to do what a monk's got to do, man. All right. So, 6 bits, so we got 6 electrons. Carbon's got 6 electrons. And why do I care about valence? Why do I care about valence? What is the importance, Deshaun?
Valence electrons are electrons that
Good. So the valence electrons are the electrons available to interact. We could say that the valence electrons are the electrons that make life possible. They make the interactions between elements possible. All right, awesome. So, I'll draw my little nucleus here. All right, nucleus is in the core. And you probably remember that an element, electrons are arranged in these, we call them like shells, right? These energy levels. You remember that? The electrons are arranged in these energy levels. And the first energy level contains 2 electrons, always 2, 2, 2, 2. One pair. Kind of interesting, right? We've been saying about how it's communities that make life possible, that make life happen, and even in an element at the most basic level of life or of rocks, takes 2 to make things happen. So, do we have at least 2 electrons in carbon? Yes, we do. So the first energy level always has 2 electrons. Come on. How many electrons then can fit in the second level? You remember, Anthony? 8. Okay? So the second level. So the first level is full. The first level is full. Is it good? Is it beneficial? Is it, yes, good and beneficial for a level to be full? It is. Absolutely. I got it. I'm all good. I'm good. I'm good. He's throwing pens at us. No, I'm not. Okay. So, the second level, energy level, can hold up to 8 electrons or 4 pairs. Now, 2 are in the first level, so I still got 4 left. They don't pair up in this outer level. They sort of, at least this is the way that I understand it, they sort of hang around and they sort of like circulate around this outer level all by themselves. Lonely little electrons. So, how many electrons are in the outermost level? 4. What's the valence of this? What's the valence of carbon? 4. So to determine the valence, that's the number of electrons in the outermost energy level. That's the valence. Now this might be, maybe this is review, but this is important. So we've got 4. Now what's awesome about carbon then, what's the importance of having 4 valence electrons? Yeah. I can bond with 4 different things. Whoa. So let's do an experiment then. God bless you. So, what's the valence of hydrogen? How many electrons does hydrogen have? First of all, what element number is it? 1, right? It's got that, it sits in the crown. That's the film finger. It's always waving at me. It's always right. Yeah. Valence of 1. Unless it's a proton. Anyways, okay. So, valence of 1. It can actually, it can share its electron, right? With carbon. So, let's put a little hydrogen here. Here's my little nucleus. And it's got, we'll make that have stripes. I guess I should make the energy level a little bit bigger. There we go. Okay. So here's my little nut. It's got stripes. And there's the nucleus. All right. Sweet. we could add 3 other hydrogens to this thing. Or we could add another carbon, we could add oxygen, nitrogen, whatever. So when you see the valence, count up the number of valence electrons that an element has. That tells you how many bonds it can possibly form with other elements, other atoms. That's important. And by the way, when we go in and you look at the different kinds of bonds or interactions that atoms make with one another, one of those kind of bonds is called a covalence bond. Covalence bond. Covalence. Well, covalent bond. That means they're sharing valence electrons. They're sharing. All right? Sweet. Let's see. Can you hear me out there? No response. Okay, good. All right. Oh, let's talk about bonds then. So what's your name? Bond. Ionic bond. Anyways, different kinds of bonds. So, what are the kinds of bonds, by the way? Ionic bonds, covalent bonds, hydrogen bonds, and then we're going to talk about something that's called hydrophobic interaction. Hydrophobic interaction. Afraid of water? Okay. All right, so let's talk about bonds. Bonds are important. All right. In some cases, let's see. So here's my nucleus. Why are there 3 out here? This must be 2. So we're going to say, oh, this must be element number. So you see the green circle there? That's 2, 3, 4, 5. So what element is that? Boron. So in some instances, this element has lost an electron, and this element has gained an electron. So if I lose an electron, what charge do electrons have? Negative charge. So if this atom has lost an electron, it's now no longer neutral. It now is going to be positive, right? Positive. And if this atom now gains an electron, which is negatively charged, it's now going to have this atom will now have a negative charge. Okay? So if you lose or gain electrons, you're going to change the charge of the element of the atom, and you change the nature of the atom. Okay, so this one on the left now has more protons in the nucleus than it has electrons out here. So it's going to have a +1 charge. And when it's a +1 charge, that's called a cation. Okay? You probably know this, but we're going to go over it anyways. If it gained an electron, it now has less protons than electrons, or we can say it has more electrons than protons. And it now has a -1 charge, and we call those anions. Anions. So an easy way I always remember what a cation is growing up. My sister had a really mean cat, and when you walk by the cat, especially on Saturday morning, cat's sitting there, it meows. I don't want to say good morning to the cat. I walk by, it rips up my ankles. Plus, kind of looks like it kind of like cut my ankles. That's how I actually remember that. Cation rips me up, whatever. Okay, that helps you great. If it doesn't, then it's just another crazy story that I told you. And you know, there'll be a lot of those this semester. So, anyways. Somebody's happy. Okay. Now, an ionic bond, once we have these ions, we can form an ionic bond, and it is none other than the attraction between two negatively charged ions. That's all it is. It's an ionic bond. It's a bond that forms between oppositely charged ions. As the saying goes, opposites attract. Opposites attract. Positive and negatives. So if you put sodium in the presence of chlorine, boom! Sorry, my mask is on. Boom! What happens? Electrons get ripped off, stripped off of sodium, and binds to chlorine, immediately forms these sodium cations, chloride anions, and then you get salt. Just happens. All right. That's the first one. And those are the strongest bonds, by the way. Ionic bonds, do you believe? Are they? Are they? I don't know. What are the strongest bonds? You guys might want to correct me, guys. Well, maybe you want to check that, Anthony. The valence bond stronger. So we'll go and take a look at that. We'll go over that on Monday. All right? See which one's the strongest bonds. Is it ionic or is it covalent? Might be covalent. Get back to me. But, so that's one way. We actually strip electrons off. We move them from one atom to the other. We form positively and negatively charged particles. We call them ions, which then form a bond. It's kind of a magnetic bond. Covalent. Covalent is sharing of electrons. And the goal, when you're sharing electrons, well, the goal, both places, all right, in both kinds of bonds, hopefully we can appreciate the fact that the goal is to complete the outermost shell, right? To fill all of those, to fill that outermost shell with electrons, so that way you have all the pairs, they're all paired up. We see that here with hydrogen, right? How many electrons are in the outermost, well, the very first shell? Two. Two hydrogens put together, they share their electrons, boom. They each sort of have now two electrons in their outermost shell. Oxygens come together. Let's do a quick exercise. Oxygen. What's the element number? 8. How many valence electrons? 6. How many electrons to complete that? 2. How many bonds can it form? 2. Can form 2. It can form either 2 separate single bonds or 1 double bond. Yo. Good. On we go. So that's what we have here. This is a double bond. 2, 4, 6, 8, 2, 4, 6, 8. Nitrogen can form a triple bond. Now this is interesting about the bond. So a double covalent bond is stronger than a single covalent bond, and a triple covalent bond is stronger than double and single. Right? Just more sharing of electrons. So these kind of bonds form when atoms share electrons. And so because carbon, we'll go all the way back to carbon now, carbon can form up to 4 different bonds. Then it can form all kinds of shapes. Benzenes, you can form chains, so you can get rings. You can have chains. All right? Fatty acids are basically long chains, long carbon and hydrogen chains. Fats. Okay, well, they can form chains, they can form rings, all kinds of shapes. And in addition to forming bonds with hydrogen, which is kind of what we see here, and other carbon atoms, carbon also commonly forms bonds with hydrogen, no, with oxygen and nitrogen. Oxygen and nitrogen. Why is that important? Why is that important? Anyone know? Yes, Anna.
Organisms are going to kind of like as much as carbon-based organisms, so that it holds together so that
Okay, so it's able to form these bonds with lots of different elements. And we're going to see that when you introduce oxygen and nitrogen into these molecules, we're going to see some unequal sharing of the electrons. Unequal sharing of the electrons. And by the way, I want to point out, when you see these lines, okay, just by way of review, we see this right here, a line that's connecting a carbon, a solid line, solid, like me. I've been working out. I did work out. Other Sean, I don't like this class anymore. He scares me. Anyway, you see the solid line, that represents a covalent bond. Covalent bond, when you see that, it's covalent. All right. You see two, that's a double covalent bond. Now, another way you can write this, I just want to get some of this nomenclature down. Because you might see these molecules represented lots of different ways, right? There we go. Sweet. So one way that you can represent a metal is methane is represented as 4 different lines like that, all representing a covalent bond. Another way to represent that is simply to write it as CH4. These are the same, right? These are the same. Okay? Let's do another one. Methanol, or CH3OH. So when you see these written in different ways, keep thinking these are all covalent bonds holding these molecules together, okay? So I just want to go over that, because you may see them represented lots of different ways in the book. All right? Yeah, keep that up there. All right? So I'm going to write this 2-amino-3-methylpentanoic acid. 3, CH2, CH, CH3, CH2, okay, this is another way to write that. Leave it up there. So we have two different kinds of covalent bonds. One is the Disney version. Everybody shares, everybody's happy. All the electrons, they're in this blissful little world. Everybody, some molecules are like that, right? Some bonds have that nature where the electrons are not, they're equally being shared. And this is important because we need these kinds of molecules. Molecules that are made primarily of carbon and hydrogen. I said fat molecules are primarily carbon and hydrogen. A lot of other molecules like oxygen. Well, yeah. The electrons are equally shared. And when that happens, you see, that's important because that allows those molecules to pass right through plasma membranes. Right? It's kind of like when we're in harmony. When we're in harmony, we can do a lot more things oftentimes than when we're not in harmony, right? Right? When we're at peace, we can do a lot of things. We can go through barriers that we normally couldn't do. It's a good lesson we can learn. But there's also molecules in which the bonds, the electrons are not equally shared. And this conveys to the molecule a different property. So we're going to pick up here on Monday. And I am going to extend the Connect deadline to Sunday night. Give everybody a chance, the Connect for Chapter 2. Going to give everybody a chance to get caught up on that so we get on the right foot, we get reading. For Monday, just reading outline. Oh, here we go. Sweet. We are going to, we're probably going to start talking about the biomolecules, especially proteins. So you would want to read through letter C at the bottom of page 2, biomolecules 35 to 39 for some basics, all right? Cool. Questions? Awesome. If we could have some volunteers help with the post-class cleanup, I'd appreciate it. And have a great weekend. Thank you. Thank you for putting up with lots of craziness this first week. It's not a problem. I'm gonna extend the deadline for assignment 2 to, thank you. Next week. So are you Philomena, sister?
I am.
You are?
Yep.
Okay.
Yeah.
It's good to see you. Thank you.
You're welcome.
So did you see the videos I posted about making the graphs and stuff?
Yeah, I'm still trying to figure it out.
Okay, so if you look at some videos to sort of give you some guidance on how to do that.
Okay. Thank you.